My name is Paul Roberts. I'm going to be doing the first part of this presentation on what's new in nCode 2018. The first thing to mention on this slide, as you may have noticed, it now says nCode 2018, so we have changed our version numbering system this year to now be in line with the year, so that's one small change. So what we're going to be looking at today is all three of the main desktop products. So I will be doing the presentation on the new things in DesignLife, and then Fred Kim will take over looking at what's new in Glyph and VibesYs. So starting with DesignLife, the major change at 2018 in DesignLife is the introduction of a brand new technology in this version focused on the analysis of welds. So this is a new unified theory of fatigue that's been developed by Professor Glyph at the University of Waterloo in Canada. So this encompasses the entire damage and the entire failure process from crack initiation through to crack growth, and has been included in 2018 as a new cost option as part of DesignLife. In summary, we have new WholeLife technology represents a unified approach to fatigue. This goes from crack initiation all the way through to final failure. And as I said, in this first release, this is targeted specifically at the analysis of welded joints. It has extended accuracy over current methods, and it's particularly well suited to the newer lightweight structures being used in automotive structures and thick welds, and particularly suited to where you are designing the weld and doing things to make the improvements to the weld itself, as opposed to designing the component and then simply welding it together. And this is a new option for welds within the DesignLife tool. So the new WholeLife Glyph, this includes in DesignLife, introduces the new technology. It uses the standard solid seam weld modeling technique. So to identify the weld location using the same technology we use to locate where that is. And it gives you the ability to analyze the detailed design of individual welds. So then you can change the individual design of that weld in detail, change the residual stress, for example, by changing the manufacturing process, and then those changes will be taken into account in the analysis. And it can analyze multiple failure modes, and it's been efficiently set up to use the standard solid seam weld analysis engine at the front of this to work out which locations to do the more complex analysis on. So we're using the standard seam weld analysis engine as the filter to pass on a smaller number of locations for more detailed analysis. Supports all the standard time-based loading, and as I said, can also include the residual stress profile at the weld, so you can look in real detail at the weld design. So as I said, there's a new DesignLife Glyph, new DesignLife engine, and also a new Glyphworks Glyph. So if you want to do this based on test data, where you've measured test data, you can do the same analysis in that regime as well. This is actually going to be covered in a lot more detail in our webinar plan for the 20th of March. So there'll be a lot more detail there. There's also, this will be presented at the GSM in Detroit next week. So there'll be some presentations coming out of that will be made available as well. So a lot more detail in the coming month. The next thing to mention, the next big change, we've been doing quite a lot of changes over the last few releases to increase the speed of the analysis and translation within DesignLife. This is more warranted because of the very large files. It needs to be quicker in terms of coping with larger and larger FE results that come through. So what we've done at this release is to enable the translation to take part in a number of separate processes. You can see here we have translating separate process being true, and at that point you then have you can add a number of translation processes. So this uses the same thread licenses as will be used for the subsequent analysis. So no extra threads being pulled and no more licenses being pulled than are already used for your analysis. And we'll split the translation into those number of processes. This is most efficient if you've got multiple load cases, for example, where it can get a very large speed up on the translation. So it saves quite a lot of time on the translation phase within design life analysis. This is an example of the speed up on this is on a 16 processor machine, where just increased the number of processes. As you can see, we get quite a lot of speed up, which then tails off slightly due to several reasons. Machine capacity. We're now trying to read from multiple places in the same file, so there's no I/O issues. So it does tail off a little bit quicker than the analysis tails off, but still quite a significant increase in speed. And for example, you can use 2 analysis processes by default without using any extra thread licenses, and this particular job was 30% faster, just with that default number of threads of 2. And there are some example speed ups that we're getting for different files. This is a little bit dependent on what's in the file, which file type it is, and quite a lot on the capacity of the machine in terms of I/O and where your files are sitting compared to where the analysis is taking place. But fastest for 16 processes, a speed up of 7 times we've seen. Another thing we have added within Design Life, I think Fred will deal with this a little bit in more detail in VibesYs, but we've added a virtual sensor to Design Life in the Design Life base. We've had for all the time Design Life existed, we've had a virtual strain gauge, so you could put a virtual strain gauge on the component and get the stresses from that location as if there was a strain gauge there. We've now added a virtual sensor, which at this release is a displacement sensor. So you can add a displacement sensor onto the model and either get the normal displacement at that point, or the result directly from the FE, or the normal and the in-plane 2-axis displacement. So this is a general purpose tool for correlating between test and CAE, but also enables you to look at adding modal assurance criteria to compare FE-based and test-based mode shape models. So and that enables that to happen from now. There will be some extra functionality added to this to look at accelerations and velocities, but currently adding a virtual displacement sensor. And Fred will cover this a little bit in terms of how this impacts on VibesYs. We have quite a number of other improvements that have been going in. So these are a number of things in terms of vibration fatigue. We've added vibration fatigue capability, vibration loading capability to most of the analysis engines now. And the last couple to add in terms of welds were the ability to do solid seam welds from vibration, and also the vibration of shell-based seam welds from force results. So this is completing most of the solver engines to be able to use vibration loads. We had a number of Python-based glyphs that were used within Design Life process. So there were 4 glyphs you see there, for a couple of them for post-processing results, and a couple for looking at modal coordinate inputs and getting and creating FE tables to run in transient or modal coordinate analyses. These have now been transferred, rewritten as standard C++ glyphs, and they're fully supported as standard glyphs and don't need Python to run. We've also added a new mean stress correction method to the SN engine. So this is the Walker mean stress correction method. This allows you to add different Walker parameters for tension and compression and be able to do the Walker mean stress correction. We up until this point, the critical plane angle calculation has been fixed at 10-degree increments. So this has now been a change so the user can change the angle. So if you want to home in on more accurately on your critical plane, you can reduce that angle, or you can make it slightly larger to reduce the number of planes to begin with. And the last one mentioned there, up until now, if you had multiple material maps defined in your analysis, you needed to go into the advanced edit screen in order to change the material setup. And the edit material maps option was grayed out on the right click menu. We've now changed that so you can go straight to material mapping without ever going to advanced edit. So for sometimes you might want to create a flow where some of the users don't have access to advanced edit, but they still need access to material mapping. So this will allow you to do that even if you've got multiple material maps. So I think that's it for the what's new in Design Life. I will just pass on to Fred.
Thank you, Paul.
Maybe Keith might have to pass the ball. Okay, I think you've got it now, Fred.
Yeah, thank you very much. Just share my PowerPoint. So thanks very much, Paul, for those Design Life developments. Now we are going to see what's new in Glyphworks, and then we'll see what's new in VibeSys. So my name is Frederick Kim, and I work just like Paul as a product manager for Glyphworks and VibeSys. So Glyphworks is general purpose signal processing, fatigue and durability related test-based signal processing tool. So the first a new interesting development we have is a new glyph, which is a new input glyph called ASCII input glyph. So previously when you had ASCII type data, you had to run it through the ASCII translate module in order to create a binary S3T file, for instance, a DAC file for Glyphworks to be able to read it and process it. So now any ASCII file with extension TXT, ASCII, CSV would appear in the available data window as ASCII files. And if you drag them onto the workspace, you'll see an ASCII input glyph generated. This one requires a setup file, which is obtained from ASCII translate. So if you always work with the same type of formatting, right, of an ASCII file, you do it once for good. You create a setup file, which defines how many header lines there are, where to find the channel titles, etc., etc. And you save it here once for good. You can have it in the preference such that setup file is always pointing to this very setup file, for instance. So anyways, depending on the content of the data, the output pad may be blue for time series or red for histograms or spectra or etc. And it'll read the data and there you go. You know, you can display or process it or anything you want to do with Glyphworks straight without having this intermediate step of using ASCII translate in the middle. Now in the ASCII translate module, we have a new option to automatically calculate the sample rates from the data. So typically an ASCII file, the first column is the timestamp of the data. And if it's ISO sampled, like the delta time is constant, there's an option, a tick box that says basically look at the first column and derive the sample rate from that first column. So those are options that enable you to work more seamlessly, in a seamless manner especially if you want to run in blindly, in batch. You've got ASCII files and you want reports containing the spectra and the rainflow cycle count and fatigue results, whatever. So you don't have to use ASCII translate and then Glyphos. You can go straight to Glyphworks. So it makes the whole process seamless. Still talking about input data in terms of file formats. We've got new file formats supported natively in the software, namely Glyphworks, Vector BLF file format, and IPtronic IAD. Both are, Vector and IPtronic are suppliers of data loggers, and more specifically for the in the automotive world for monitoring, the CAN bus. So they produce those file formats which contain typically CAN data. So we read them natively in the software now from version 2018. And we did a number of enhancements to existing file formats. The HBM Catman bin file is now supported on Linux. It used to be only Windows previously. The OXF file is now available on Windows 64-bit. So previously was Windows 32 only. We got a faster access to DBsoft DXD files. It was kind of slow. We updated the library for reading these files, and it's much faster now. So a wide range of file formats. OROS are typically used for NVH type, like vibration acoustic applications, and DBsoft are it's pretty generic type application. HBM Catman is in part of our group, right? Of course, and so those are files that have been file formats that have been enhanced. Now coming back to CAN data, the Vector MDF file and the ETAS MDF file formats have been enhanced. Now we can do an automatic resampling to time series. So typically CAN data is time stamped. So in Glyphworks it doesn't appear as time series, it appears as multi-column. The difference being time series are only for ISO sample data, constant sample rate if you prefer, and multi-column is generic data with maybe a column containing the timestamps. So you're pretty limited when you're on multi-column to analysis, to like you can't do FFT-based analysis. So you sooner or later you'll have to resample anyways, depending on what you want to do. But now the enhancements is that on the fly, when you read this MDF file, it'll automatically resample it to a constant sample rate. So we've got a number of options in the preference here to do that automatically for you. So that's it in terms of file formats. The idea, since you noticed most of the file formats have to do with CAN data, the idea is to streamline the usage monitoring type application and the ADAS validation activities by reading natively the data coming from the CAN bus from the vehicle network. We've got a new Glyph now when it comes to processing. We got this stress and strain conversion Glyph. So the idea here is to do conversion from elastic linear strain to elastic plastic stress and strain, for instance, or the opposite way around, elastic plastic strain to elastic stress and strain, or elastoplastic to elastoplastic. The idea here is that you'd use a material with its like this carbon steel here in the screenshot. This material is coming from the material database, and it comes with its characteristics and the material curve that goes along, and it enables us to calculate the elastoplastic strain and stress based on elastic strain, etc. The idea here is, you can then from the stress time series and strain time series, say they are elastoplastic here, you can cross-plot them and view the hysteresis loops. So basically, by doing so, you can visualize, graphically observe the amount of plasticity that is contained in your measurements. And another use of this glyph is to enhance the comparison and the correlation between test data, which is measured strain, which contains a given amount of plasticity, say, with CAE data, which is sometimes elastic, so purely linear. So you may want to do those conversions to enhance the comparison. Then what we have next, still in terms of processing, we've got this running statistics glyph. So typically this glyph might exist in Glyphworks, and it does typically today the max or the mean or whatever statistic value you're after, every second, say, or every so many seconds, with or without an overlap, a user-defined overlap. Now we've added this new capability whereby the running statistics goes on a feature-by-feature basis. So let's take this example here. We've got some measured data. It's coming from a vehicle. And here we're using this TS calculator to identify the sections in the data where the speed has exceeded 80 miles per hour, for instance. So those sections are the green ones that you can see here, and they are defined in this orange pipe here. So we're piping this into the running stats, and we're asking for the maximum, say, every section. So we end up with 1, 2, 3, 4 points, which gives us the maximum vehicle speed, for instance, the maximum longitudinal acceleration, etc., on a event-by-event basis. So no longer relying on the time vector. So you got a choice now. You can do such statistics. The interesting bit here is this time series output showing you the stats on a section-by-section basis. You can now do you can continue the analysis. You can do a histogram saying, for instance, how many times the maximum speed exceeded, or the maximum engine temperature. You can bin that in a nice histogram. How many times has it exceeded this value every time? The brake pedal, or you can imagine all sorts of analysis based on events like that. Now, in terms of display, displaying data, in the XY display, which is typically used to display time series or spectral histograms, 2D histograms, we've got a new preference to define a number of decimal places or significant figures that are displayed when putting cursors on the data. So you can decide to go in high precision like that, or round it to far less, figures after the comma. Also, in terms of displaying multiple channels, if you have hundreds of channels, you may just want to display a very limited number of those channels, and you want to, instead of browsing through this endless list, you may just want to enter the channel titles like that, because for instance, your channel titles, so you can do that now. Once you get the selected channels, they're displayed in order typically, and say you want to display the number, the fifth and sixth channel first, so you may select them, and you've got these arrows now to change the order of the displayed channel. It's it's nothing revolutionary, but it makes your experience with the software a bit more pleasant when it comes to changing the order of the displays. What else? Yeah, the cursors and the annotations on the top of the curves were not enabled when you had multiple y-axes. So that's now been addressed in version 2018. You can have cursors and annotations on XY displays if you have multiple y-axes. Other displays, the data values display. Some of you might have noticed that if you click on the top of a column, it sorts the table right? According to that column, if you had huge quantities of data, it could be slow. Now it's been optimized, so we've got outstanding enhancements in terms of performance in here. And the nCode viewer, now you can run the nCode viewer using a command line. Now we've added to that command line an extra argument which enables you to use a given configuration file. So that means the data you point into will open in the viewer, but with given display settings, like so many y-axes, multi-overlays, those colors, and thicknesses and grids, and etc. etc. So that enables you to really quickly display the data the way you want it to be displayed. So all these enhancements in the display have been made with the objective to get faster and easier to conclusions from just displaying the data, right? The results or the raw data. But purely graphically, you should be able to use your engineering knowledge to take decisions based on that, and we made all this to make this task easier. So that's it. That was it for GlyphWorks. Now let's move on and let's have a look at VibesYs here. So VibesYs is for vibration and acoustics analysis, and in version 2018 we made a few enhancements, starting with the virtual sensor. So as Paul was describing it, you can position a number of those sensors on your model, FE model, and these sensors will capture the displacement at that location and direction. So you can mimic basically a triaxial accelerometer, for instance, right? It'll capture the displacement normal to the surface and two displacements within the surface. Obviously, you can rotate it to match with the accelerometer that you've positioned on the physical component, which sits on the test rig, for instance, or in real conditions. And they'll extract the time series. Obviously, as Paul mentioned, it's displacements only, but there's nothing stopping you from doing, double integration, double differentiation to move from displacement to acceleration or the other way around. And therefore, this helps in the correlation exercise between correlation between tests and CAE and tune your FE model. But the reason why this slide is also in VibesYs is because some of our users want to do the model assurance criterion. So it's in other words, you want to compare the mode shapes, how similar they are. So you want, instead of looking at time series of displacements like that, you want a single scalar value per mode shape. So let's compare the mode shape from my physical measurements with the mode shape calculated from my favorite FE code. So you want to end up with a matrix like mode shape from test. How does it compare to mode shape 1 from test? How does it compare to mode shape 1 from FEA? How does it compare from mode shape 2 from FEA, etc., etc. So this enables that we can easily produce this histogram now, this matrix now. What else? Still in terms of animation, we've got this operating deflection shape glyph, which enables you to animate a wireframe type structure or an FE model by mapping some measurements to it. So typically you'd take a measurement, whether it's an FRF or time domain signal, and you map it to this specific node, for instance, in this specific direction, and then you can animate the whole model. So what we did in version 2018 is the ability to plot those boundary conditions, if you like. So we can plot the nodes that are fixed by the user using triangles like that, showing that the node has been fixed, and using an arrow we plot here where and in which direction there is the channel has been mapped. So that helps indeed understanding or that helps validating that the mapping has been done correctly. It's also possible to plot the channel number, so I could see that here at this specific node in this specific direction it's channel 12 that's been mapped, and this specific node this other direction is channel 13, for instance. See here in this example, I could easily catch an error I made in terms of polarity, maybe, or I did it on purpose. Maybe the sensor that was sitting here was not in the right orientation or something. But that helps basically validating the mapping. In terms of vibration analysis, so we've got a vibration manager in ASCII where curves from various vibration standards sit. So we have, for instance, the vibration curve from the mill standard 810, vibration curves from the DO 160 and the DEF standard, etc., etc. Now we added a new entry, which is the ISO 16750, which is for road vehicle environmental conditions and testing for electrical and electronic equipment. So you've got all the profiles that are defined in this standard available in the vibration manager, and you can use them. You can pick and choose which profile and use it in ASCII or Glyphworks to compare, for instance, with your measurements, to use it as part of your test tailoring activity, your accelerated testing application, for instance. So this is really the primary use of that is to compare the severity of your synthesized qualification test with what the international standards require.